Hey, welcome back. So, have you ever stopped to think about how a game just knows things? How it remembers your health, keeps track of your score, or knows you just picked up a key? Well, the secret to all of that is one of the most important ideas in all of programming: variables. Right now, our little game project is, well, it's pretty rigid. It does one thing, and that's it. In this explainer, we're going to tear that rigidity down. We're going to learn how to use variables to store information, to make our card dynamic and responsive, and really transform our code from this static block into a flexible system that's actually fun to tweak. Let's get into it. Okay, so here's the game plan. First, we're going to go on a little hunt for something called magic numbers in our code and figure out why they're such a pain. Then, I'll introduce you to the solution, variables, and the best way to think of them as little boxes for our data. After that, we need to learn the language, right? So we'll cover the basic data types in C#. Then we're going to immediately jump into a hands-on coding session to put it all into practice. And we'll wrap up with a little challenge for you so you can really take the wheel and make this knowledge your own.
All right, first things first, let's figure out what's wrong with what we have. Right now, our game works, but it's brittle, you know? It's like it's been set in concrete. We're going to look at a very specific bad habit in coding that causes this, and you'll see exactly why the way we've written our numbers is stopping us from making our game fun, interactive, and just plain easier to work with.
Okay, so if you pop open your script and you look inside that update method, remember, that's the code that Unity just runs over and over again, every single frame, you're going to find this line. This is what's making our car turn. Transform.rotate. It needs 3 values, one for X, one for Y, and one for Z. We've told it, don't rotate on X, don't rotate on Y, but rotate by 0.1f on the Z-axis. Now look really close at that number, 0.1f. In the world of programming, we call that a magic number. It's just a raw number dropped right into our code with no explanation. And while it works, it's a huge problem waiting to happen. So you might be thinking, why is this a bad thing? The car turns, it works. And you're right, it does work, for now. But it is completely inflexible. Put yourself in the shoes of a game designer for a second. What if you want to test out a faster turn speed? Or maybe you want a power-up that gives the car better handling for a few seconds. With this hard-coded number, you'd have to stop the game, dig into the script, find this exact line, and change that number every single time. And imagine if you use that number in 10 different places. You'd have to find and change all 10 of them. It's slow, it's easy to make a mistake, and it makes it impossible to change the car's behavior while the game is actually running. So if magic numbers are the problem, then what's the fix? Well, the solution is super powerful and actually pretty simple. It's variables. And the absolute best way, I mean the best way to think about a variable is just as a labeled box. That's it, a simple container that we can create to hold a piece of information for us. Instead of just throwing our numbers all over our code, we're going to put them in a nice labeled box where we can always find them. Okay, let's get just a little more technical for a second. The official definition is a named container. That's the key. We give our container a name, we put some data inside it, and from that point on, we don't really have to think about the data itself. We just use the container's name. We can peek inside the box to see its value, we can swap out the value for a new one, and most importantly, we can use that name in our code instead of a raw number. This is really the key to writing flexible and readable code. So, every single variable is made up of these 3 essential parts. You can think of it like the label on our box. First, every variable has a name. This is how we find it, like hit points or player speed. It has to be unique. Second, it has a type. The type tells the computer what kind of stuff is allowed in this box. Is it for whole numbers, decimal numbers, text? This stops us from accidentally trying to put a player's name in a box that's meant for their score. And finally, there's the value. That's the actual data that's inside the box at any given moment, like the number 20. Name, type, and value. You'll find all 3 in every variable. And here's what those 3 parts, the name, the type, and the value, look like when we actually write them in C#. This one line of code does it all. First, we have int. That declares the type. It tells the computer, hey, this box is only for integers, whole numbers. Next, hit points is the name we've picked out for our box. Then the equal sign, that's what actually puts the value inside. And 20 is the starting value. And finally, that semicolon at the end is like the period at the end of a sentence. It tells the computer we're done with this command. The whole process is called declaring and initializing a variable. Okay, before we can start creating our own variables and fixing that magic number problem, we need to learn a bit of the vocabulary. We have to know what kinds of boxes or data types C# and Unity give us to work with. Choosing the right tool for the job is half the battle. This table right here shows the big four. These are the data types you're going to be using all the time. First, you've got int for integers. Any whole number, positive or negative. Perfect for things like your score, how many lives you have, or your ammo count. Then there's float, which is for any number with a decimal point. This is what you'll use for anything that needs precision, like speed, or time, or an object's position. Next up is bool, short for Boolean. This one is super simple. It can only ever be true or false. It's the basis for all logic, perfect for tracking things like is player alive or is door open. And finally, we have string, which is how you store text, like a player's name or a line of dialogue.
Let's focus on the float for a second because we're about to use it. Floats are your best friend for anything that needs decimal precision in a game. Speed, time, distance, rotation, you name it. Now, look at that example. Float speed equals 3.8f. That little f at the end is so important, I can't stress this enough. See, by default, C# thinks any number with a decimal is a more precise type called a double. And while that's fine for science, it's usually overkill for games and can actually cause errors in Unity. So that little f is you telling the computer, nope, trust me, I want this to be a float. Just get into the habit now. If it has a decimal, put an f at the end.
Next is the bool, or Boolean. Don't let its simplicity fool you. This thing is the foundation of all decision-making in your game. It's basically a light switch. It's either on or off, true or false. You use it to ask questions that control what your game does. Is the game paused? We check a bool called isPaused. Did the player find the key? We check has key. Based on whether these are true or false, we can open a door, show a menu. It's a simple idea with incredible power.
And finally for today, we have the string. Anytime you need to work with text, this is what you'll use. A character's name, a message that pops up on the screen, dialogue, it's all strings. The most important rule here is the double quotation marks. They're a signal to the computer that says, hey, everything between these two marks is just text. Don't try to run it as a command. If we wrote my name equals Rick, without the quotes, the computer would go looking for a variable named Rick. By adding the quotes, my name equals Rick, we're telling it to just store the letters R-I-C-K inside our my name variable.
All right, theory time is over. Let's get our hands dirty and actually see how this works inside our script. We are going to take everything we just learned and use it to finally fix that nasty magic number problem we found at the very beginning. We're going to follow these 5 simple steps. First, we'll pick a location. Where you put your variable actually matters a lot. Then we'll declare its type, which for us will be a float, and give it a good, clear name. After that, we'll assign it a starting value, the same one our magic number had. And finally, the most important part, we'll actually use the variable, swapping out that raw number for our variable's name. This is the step that gives us all the power. Okay, step 1, location, location, location. Go ahead and open your driver script. You'll see public class driver mono behavior at the top, followed by an opening curly brace, parentheses. That space right after the opening brace, but before void start, is what we call the class level. This is the perfect spot. Why? Because any variable we create here becomes a member variable, which means all the methods in our class, like start and update, can see it and use it. If we put it inside start, only start could use it, and that's not what we want.
Now for steps 2, 3, and 4 all in one go. Right in that space we just talked about, I want you to type this line out, float steer speed equals 0.1f. Let's just break that down one last time. Float is the type because our steering value needs a decimal. Steer speed is our name, it's nice and descriptive. The equals sign assigns the value, 0.1f, which is the exact same magic number from before, and we cap it all off with a semicolon to say we're done. Perfect.
And here is where it all clicks. This is the final step. Now that our steer speed variable exists and it's holding our value for us, we can actually use it. So scroll down to your update method, find that transform.rotate line, and completely replace the hard-coded number 0.1f with the name of our variable, steer speed. Now, every frame when update runs, the computer sees steer speed, looks up the value inside that box, and uses that for the rotation. Our code is now officially flexible. Just take a second to look at the difference here. On the left, we've got the old way, a magic number. If you came to this code for the first time, you'd have no idea what 0.1f is supposed to be. It has no meaning. But on the right, we have steer speed. The code now explains itself. It's self-documenting. And even though the car will drive exactly the same for now, our code on the right is so much better. It's more readable, it's easier to change, and it's just more professional. All right, now it's your turn. The absolute best way to make a new skill stick is to try it yourself. So to make sure you've really got this, I have a little challenge for you. Time for you to get behind the keyboard and take control. Here's your mission. Our car's turning is now controlled by a variable, but its forward movement still uses a magic number. I want you to fix that. You're going to create a new float variable, call it move speed, give it a starting value of 0.01f, and then use that new variable in your transform.translate method. Go ahead and pause the explainer right now, jump over to your code, and give it a shot. I'll be right here when you're done. Hey, welcome back. How'd it go? Let's take a look at the solution. Your script should now have a second variable, right there at the top. Float move speed equals 0.01f. And then, down in your update method, the transform.translate line should now be using move speed for its y-axis value. If your code looks like this, then awesome job. You just successfully created and used your second variable. So, you might still be wondering, what was the real point of all that? We did all this work, and the car still drives exactly the same. Well, now we get to the payoff. This is the aha moment. We're about to see just how much control we've gained by making one tiny change in one easy-to-find place. Go back to your script, find that steer speed line right at the top, and all I want you to do is change its value from 0.1f to just 1f. Just delete the 0. That's it. We just made our steering 10 times more powerful with a single key press. Remember to keep that F there so C# knows it's a float. Now make sure you save your script, Control-S or Command-S, and pop back over to Unity. Hit that play button, and look at that. The car is spinning like crazy now. The forward movement is the same, but the rotation is 10 times faster than it was. We just completely changed the entire feel of our car's handling by changing one single number at the top of our script. No more digging around required. This is so great for just playing around and finding what feels right. Let's try one more thing. Go back to the script and change that steer speed value again. This time, try -0.05f. Now think about it for a second. Making the number negative should reverse the direction of the turn, right? And making it smaller than our original 0.1f should make it turn slower. Let's see if we're right. Okay, save your script, hit play in Unity one last time, and yep, there it is. The car is now turning slowly, but in the opposite direction. This is the flexibility, this is the power that variables give you. We can now experiment and tweak our game mechanics with incredible speed, all because we have these nice, neat little control knobs at the top of our code. So really, the big takeaway here is that we've made our code dynamic. We've basically built a little control panel for our car right at the top of our script. Instead of digging for numbers, we have these clearly named knobs like steer speed and move speed that we can just tune to get the exact behavior we want. This is a foundational skill for writing clean, professional code. We have taken a huge leap forward today, but you probably noticed we're still jumping back and forth. Tweak the script, save, switch to Unity, play. Tweak, save, switch, play. It's better, but it could be even faster. So that leads to one final exciting question. What if we could just change these values without ever opening our code again? What if we could have sliders and number fields for our variables right inside the Unity editor and tweak them while the game is running? Well, in the next explainer, we're going to do exactly that. It's going to change your workflow forever. See you there.